Welcome to this lesson. In this lesson, we are going to learn how to derive the chain rule, still using the first principle method. So if you are with us and still you haven't subscribed, pause the video whilst you subscribe and hit the notification button. Give us a comment, let us know your mind in the comment box so that we can know how we can deal with you. Thank you. So now we go into the lesson. While we still recall from the first principle, we realize that we first have the limit as our h approaching 0 of our function at x plus h minus the function at x all over h. Alright. So in this, we are now going to use this to find the first derivative or find the derivative of this. A function that is of this form, which is now going to give us my dy, my dx is going to give me what? My limit as h approaching 0 of a function multiplying what? My g of x plus h. My g of x plus h. Alright? My g of x plus h minus my f of the function g at x. The function g at x. Okay. The function g at x. All over h. All over h. Okay. So now that we have this, what can we deduce? We can have that my dy dx is going to be equal to my limit as my h still approaches 0 of the function at what g of x plus h. G x plus h, this minus my f of the function at what? G of x. Okay. So here is what my g of x. Now over here, I'm going to multiply everything by 1. I'm going to multiply the whole function by 1. Whenever we have g of x plus h minus my g of x, all divided by g of x plus h minus g of x. When you have something like this, it is still 1. The numerator and the denominator are the same, so they cancel out, so it's still 1. So I'm going to multiply the whole of this with the 1 over here, which is going to give me my g of x plus h. Alright, so let's do this. So this is going to give me my g of x plus h minus my g of x all over my g of x plus h minus my g of x. Alright, so now let's think of a function of this form. Whenever I have 1 over 2 times my 3 over 6, this function over here is still the same as 1 over 2 times, okay, no, this is the same as, okay, over 3 over 6. This function is the same as, let's look over here, okay, so this function is the same as 1 over 6 times 3 over 2. So because multiplication is what? Commutative, we can shift the denominators. Even if we shift the numerators too, we have still not changed anything. So here we are going to swap what? The denominators over here. So when we swap the denominators, what will now our function look like? I still have my dy dx giving me limit as my h approaching 0 of a function of g of x plus h, my g of x plus h minus my f of g of x, Now we are swapping the denominators, but first let's bring this guy. This is multiplying my g of x plus h minus g of x, but we know that the whole of this guy, we are shifting what? The denominator. So here, instead of h, we now bring the whole of this. So this guy shifts here while this guy also shifts there. So we are now going to get, we are going to get what? We are going to get we are going to get g of x plus h minus my g of x. Now here we now going to get what? My h at the bottom there. My h at the bottom here. So, but mind you, we can spread what? The limit over, which means that here I'm going to get what? Limit as my h approaching 0 over there. And but, so what would this guy look like? What does this guy look like? This is looking like what? This is the first derivative or the derivative of the function of x, the function of g of x, which is this one, the derivative of g of x. So we can now put this as what? My g prime of x. Okay. So I've now gotten my g prime of x. Now let's focus on the left hand side. And focusing on the left hand side, we are going to get limit as my h approaching 0. But let's consider this. Alright. Let's consider this. So first we are first given what? F of what? G of x plus h. So here is g of x plus h minus my f of g of x. Okay? So this is what? F of g of x. This is what? My g of x all over this whole denominator. But this whole denominator, let's see, let's make the whole denominator to be equal to some k. Because it's being clumsy, let's just make it to be equal to some k. So where we are going to get what? My g of x plus h minus my g of x should be equal to some k. But we know limit as our h is approaching 0, my k too should be also approaching 0 over here. So as h is approaching 0, my k is also approaching 0. But over here too, I can also make what? My g of x plus h the subject. So when I make my g of x plus h the subject from this relation, I'm going to get my g of x plus h is going to be, well, is going to be g of x plus my k. Okay. So we are now going to do this substitution back here. We didn't change anything. Wherever we see our g of x minus g of g of x, we are just going to put our k here. Whilst our h is approaching 0, the k is also approaching 0. Whenever we see our g of x plus h, we are replacing it with our g of x plus some k. So that is what we are going to put here. In that, we are going to get my limit as my h still approaching 0 of, okay, first let's put the denominator here. In this case, we are going to get the whole denominator here is going to be what? My k. So here I put my beautiful k here. Then we continue by saying that everywhere that we see our g of x plus h, we are going to replace it with what? G of x plus k. That is going to be give us f of, that is going to give us f of what? This is g of x plus h, so this is what? G of x plus k. So we now put our g of x plus some k over here. Alright? Or minus my what? G f of what? My g of x. Alright? And the whole of this is going to be over my k. But mind you, this is what? Let's look closely at this. When you have a function that is our limit as our h still approaching 0 of our f prime of what? A plus k minus my f of a all over my k. So let's say some k approaching 0. All of this is equal to what? Oh, sorry, this is what just f of, so this is not there, this guy is not here. Alright, beautifully we have taken it off. So we are having what? A plus some k. All of this is equal to our f prime of a. So it's still the same thing. So all of this over here is just what our g of x. So here we are just getting what our f prime of g. So instead of a, here is what x over here. So the whole of this is just what f prime of g of x, f prime of g of x. So finally, and that is multiplying what g prime of x over here. So it means finally our chain rule now gives us what our f prime of g of x multiplying by g prime of x. Hence, we have proved using the first principle, we have proved what the chain rule. In our next or coming lessons, we are going to use this that we have proved to solve a lot of examples or similar examples where students will be familiarized with these concepts. Thank you.